to my maths class. Today I'll be teaching calculus, and under calculus I'll be teaching differentiation, and I'll be starting from what is called the first principle. So differentiation simply means taking a function to derivative. Okay, so how do we solve using first principle? Let's say we have y equals x, right? So we are differentiating s with respect to y from first principle. So for every increment in y, there will be a corresponding increment in x. So we say y plus change in y will be equals x plus change in x. This is just the typical way of solving from first principle, or using first principle. So we have y plus change in y equals to x plus change in x. Then we have change in y equals x plus change in x minus y, right? So we have change in y equals to x plus change in x minus y. Y equals x from function, so we can replace x to be equal, y to be equals x. So we say change in y equals to x minus x plus change in x. So this cancels this. Then we can say change in y equals to change in x. So we divide both sides by change in x. So we have change in y over change in x equals change in x over change in x, right? So we limit both sides by saying change limits. Okay, before then, since this is change y change in x, this crosses this, so we can say change in y to change in x equals 1. Then we can take it to limits by saying limits of change in y over change in x as change in x approaches 0 is equals to the limit of a constant 1 as change in x approaches 0. So the limits of change in y to change in x is equals to the y dx. Also, the limit of a constant as the x value approaches any given value is also equals to the constant itself, 1. So dy dx equals to 1. So this is how you solve from first principle. I hope you understand that. Okay, let me solve more question. Let's say we have another question like this: y equals to x squared. All right, so if we have y equals to x squared, we can say we have y plus change in y equals x plus change in x all squared. So we say we have y plus change in y equals x squared plus 2x change in x plus change in x squared. Then we can say change in y equals x squared plus 2x change in x plus change in x squared minus y, right? This y is coming to this side. Okay, so by collection of like terms, this y comes here. Good, I believe you understand that. Okay, so change in y equals, this is x squared. We have x squared plus 2x change in x plus change in x squared minus y, and y equals x squared. So we replace y to be x squared. Okay, so since y equals x squared, we can go ahead to say change in y equals this x squared cancels this x squared. So we have 2x change in x plus change in x squared. Change in y equals to 2x plus 2x change in x plus change in x squared. So what is common between both of them? Change in x. So since change in x is common, we have change in x into bracket 2x plus change in x, right? Good. So divide through by changing x. So we say changing y over changing x equals changing x into bracket 2x plus changing x over changing x. Good. This changing x crosses this changing x, so we have changing y to changing x equals 2x plus changing x. So we can take limit of both sides by saying limit changing y to changing x as changing x approaches 0 equals limit 2x plus changing x as changing x approaches 0. So changing x to changing y becomes dy dx equals we have limits 2x plus changing x, so we have 2x plus changing x 0, right? Good. So we have dy dx to be equals to x, and that's our final answer. So I believe you understand this as well. Okay, if I'm too fast, you can rewatch the video and then take it slowly. Okay, all right, let me do one more question. One more question. Let me solve one more question. So let's say we have this. I love this. Y equals to 1 over x. So when we have a question such as y equals 1 over x, how do we solve this kind of question? So we have y plus changing y to be equals 1 over x plus changing x. So we have changing y equals 1 over x plus, sorry about that, 1 over x plus changing x minus y here, right? So we have changing y equals to 1 over x plus changing x minus y, which is what? 1 over x. So we have changing y equals 1 over x plus changing x minus 1 over x. We have LCM. So we say our LCM is x plus changing x into bracket x. Then we have x plus changing x. In this LCM we are left with x times 1, we have x, then minus x, we cross this x, so we have x plus changing x. So changing y equals, we open this bracket by saying x minus changing x over x plus changing x, then x. This x crosses this x, so we have changing y equals to minus changing x over x plus changing x multiplied by x. So if we have changing y to changing x, this will be equals to minus changing x over changing x into bracket x plus changing x, then x. So this crosses this out, so we have changing y to changing x equals to minus 1 over x plus changing x, sorry about that, x plus changing x and then x. So we have the limits of changing y to changing x as changing x approaches 0 equals the limit of minus 1 to x plus changing x, then x. So when we take the limit of both sides, we have dy dx equals, when we take the limit of this, we have minus 1 over x plus, so the idea, okay, sorry, yeah, changing x approaches 0. The idea is anywhere we see changing x, we plug in 0. Okay, so we have x, so we are left with dy dx equals to minus 1 over x. So we have dy dx equals to minus 1 minus 1 over x squared. So this is how to solve this question. So I hope you enjoy the video. So if you have any question, just let me know in the comment section. Post your comments, and then I'll be right there to answer your question. And if you have any topic or any question you want me to solve in calculus, you can also post the question. So let me leave you without any assessments. So let me give you this from first principle. Solve using first principle. Y equals to the square root of x. Okay, so that's my question for you. All right, thank you so much. God bless you all for joining the class.